hosting a AMA session afterwards. So first, we are going to tell you guys who we are and what we've done and what we do. We are AstroX Network. We are founded by Fast and Apps. We are building tools and infrastructure since 2018 for Silicon Harmony, Portal, and IC. We are on IC focusing on building infrastructure for cross-platform developments and building products around users and developer communities. We have some portfolios we are doing. We already developed a agent Dart, which is a basic SDK for mobile or cross-platform clients on IC, and we also have AstroX Mini and AstroX Mini Plus, which is a identity service and apps. And we have Touchcoma. Touchcoma is a mini app framework for developing web rendering projects on IC, and we are also developing various protocols like identity protocols, mini app protocols, and also importantly IC Connect protocols. We're covering the later three sections for the later part, but we are talking about Agent Dart today. So Agent Dart, this is the main topic for today. Agent Dart is a basic SDK for building cross-platform client on IC. Without it, we don't have Flutter interacting to IC anymore. So to solve the mobile development on IC problem, we have to use the agent agent to interact with the internet computer. Dart lang is the very commonly used for cross-platform development for Flutter. So let me show you agent Dart first. This is the agent Dart repository. In a sense, it is a very standard Flutter plugin package for Dart and Flutter apps. You can see different folders here. See Android, iOS, Linux, Mac OS, Windows, indicating this plugin is already cross-platform for the major client platform on the computer and the mobile phones. So the agent Dart, you can use agent Dart to build Android apps, iOS app, Mac desktops, and Windows. Even last week we also officially declared you can use agent Dart to build web apps as well. So the Flutter and Dart is so powerful, but it does have some pros and cons. First, we are talking about the cons. Because Dart lang is a new OOP language for developers, it's not very popular choice and RN by web and JS developers. JS developers they all love RN for some cases, and it's not fully aware and understood by blockchain developers. So most blockchain developers love the web, the web only. They are not very like the mobile things, cross-platform things. So we are minorities, to be honest. However, the pros is very attractive because you can use Flutter to write once and run everywhere because it's already cross-platform. The Dart lang is a type-safer language than JavaScript and TypeScript. It runs average 60 FPS in production, so it's very high performance. And it has interoperability, and you can use native code and use devices from cell phones and other desktop to interact with your app. And then they have a declarative lines and richer interfaces than the web. So the pros is very interesting. So we decided to develop this package to allow developers to develop Flutter apps to interacting with C. So this session we will be covering Agent Dart a little bit. We have a closer look at Agent Dart about how it works and how we use it. So we go back to this code base. Agent Dart have different folders here. Don't be scared. And this folder actually we are not organized to desktop to this folder. From the left side, we have different layers for packages. We have crypto layer, we have encoders, decoders layer, and the HTTP layer. This layer will it actually contain different packages here. And to the right, we have application packages. We have identity packages, or Postlion, Ledger, Rosetta, Signer, and any other. This application packages are almost combined with different layers. For example, the identity package is actually using ED 25519 and SCP 256K1 combined with BaseX and Candid, and we and also have the actor to complete the identity packages. So the other packages as well, like Signer, we have ED 519 SCP 56, and we have Seaboard to complete the Signer. About the Ledger is much complicated than any of the packages. We have certificate actor, postget, and we have almost here to complete the Ledger package. So this is the very basic level, and this is the application level. To do that, we almost porting every useful piece of Agent.js which is developed by the Definitive Foundation. This Agent.js was made for the web developers, but we are using web porting almost every packages from Agent.js. You can see almost every folders are identical to that, but we enhance some features for Flutter. So you can see the Agent Dart is an enhanced version for mobile, and we have similar almost the same interface APIs to the Agent.js, and almost the same. So the web developer, when they are switching to the Flutter development, they can use almost the same the paradigm using the logic and reuse the code from Agent.js. So let me cover it later. Okay. So the next part, I'm going to tell you the basic pattern using the Agent Dart, the diagram. We have a diagram picture here. To the left side, you can see a canister. The canister is composed by the WebAssembly and the Candid file. This tool will generate a IDL. The IDL is a interface description language to describe how we can interact with the WebAssembly code and with the client code. you can see IDL is a glue code distribution language from both sides. The IDL will as an input to agent factory here. To the right side, we have identity as another parameter to the agent factory. The identity will get from auth client. Auth client will hook up with identity, non-identity, and other wallet environments. And the auth client will get identity from other provider and combine with the IDL to the agent factory. And then agent factory will generate the product. The product is a multiple agents here. No matter how many canisters there, they can generate different agent here. You can have many agents inside your app. These agents you can either use them to the services, or you can just describe and you just use the UI code to composing together. UI code here. So you see the upper level is the business logic, and the level here is the UI logic. So it's a business logic and UI logic, and it's the agent factory to connect both. So let me show you the example that directly, and I think you have visually understand how we are going to use agent to make different applications. So we have 3 examples. The first, we're going to show you a simple introduction to the canister, and the second one is how to get authorized from the II. The third one is to transact ICPs from A to B, from address to bar, to one address to another account. So the first one is the counter. The counter is very simple. When you're developing the Flutter app, you may by default we have a sample code for your app. It's called the counter. The counter app in the Flutter is very simple, and when you click the plus button, and we increase the number, and when you refresh the application, the counter will going back to 0. But here we are using another paradigm for the counter because we want to use the ability from the canister, and we use canister to host the counter increments. So the counter results, the value will be stored in the canister running on the blockchain. So let me show you the code directly. But let me run the example before I explain code. So counter here. To make counter works, we have to look at the model code to the backend. Model code here is very simple. We have 2 different functions. One is the increment. One is the get value. When you interact with increment, the current value will increase by 1, and the stable variable current value will be increased by 1. And then you call the get value, you can get the value back. So because we are using stable variable here, we see the current value will be stored stable in the canister. So basically it won't change after your application is over. Let me show you the main application here. The application is very simple. It's basically a copycat from the Flutter example demo. We also have a Flutter floating action button to press to increase, but the increase logic is different. When we click the increase button, the counter increment will be called. The counter increment is actually calling the canister function. Before that, we have an initial counter function here. We have a canister ID of the canister and passing the URL and canister ID to initiate the counter class. And then we increase the counter and we get the counter back. And also, interacting with the code to the IDL. So about the IDL, we have a counter class and an abstract class of counter method. Abstract class of counter method, we have a IDL distribution here. If you're already familiar with the JavaScript version, you can see. I'll show you. You see the generated JavaScript function, the IDL, is very similar to the counter class here. You can just copy paste the IDL here. Just copy paste it because we in Agent Art we are using almost the same interface API to the Agent.js. We just copy paste the IDL here. And then we can generate the IDL for the counter. Then we have a counter class. Why we have counter class? Because we want to pass the latest actor. Latest actor here. Actor is combined with the canister ID and identity and the IDL. When you pass the actor here, the actor will inside the actor, it will have the latest IDL, latest canister ID, and latest every setting for the HTTP call, and then use the actor will get the function name, and then we call the parameter, and then we will eventually call the function to the motor code functions. It's basically the same paradigm to the JavaScript version, but we have a more Flutter based, so Dart based. We use the Dart logic to write that. So let me show you the demo. So we open up the demo, run the demo. You can see the canister counter is now 6. Because I clicked the button before, so it's 6. When I refresh the restart, the application is still 6. When I click, it's a 7, and then I restart. It's also 7, not changing because it is stored to the canister. It's stored to the when you run in the blockchain, so it is stored in the blockchain. So this is the first very simple example. And second, a little bit complicated. Example. Okay, the second one is the auth counter. What is different between auth counter and counter? because it's the auth, because we are using the II to identify if you are authorized or not. In the counter example, we don't have a identity to identify the user is authentic or not. But when in this example, we will use the inside logic for authenticating logic to the counter, and then not authorized user will not allowed to click or not allowed to increase the number. So let me demonstrate the feature. First, we look at the backend object. A little bit different from the last one, especially to the increasement object. We have a equation function here to see if the color, the color is anonymous. This indicator, this account from the text, this one, is indicated that the color is anonymous. If it is anonymous, and then we show, we throw the error object, and that is not authenticated. Otherwise, you can increase the number by 1. So, if we don't have a correct ID, correct authentic ID, like II, like other wallet provider provide you the identity, it will, by default, it is anonymous. Anonymous account is like this, so not authenticated. No, this is not a production code, so don't use it in your production. I just show you the concept and show you the idea, the paradigm here.
5秒钟不多啊，太少。
Okay, let's see the counter class. What is the difference between the counter class and the last one? It's the same because the IDL is the same. The set agent, increment agent, and get value is the same. But however, how we call the class is different. Here, let me show you the main function. It's different because we have to set agent before we call the count. Otherwise, it will show that you have not logged in, or it will reject. So we have another login button. So why don't we show you that? Now you see the visual one. You have not logged in. The canister color is now 5, and when I click the increment, it will happen. Now you have a reject, and the call was rejected because your personnel is not authenticated. The count is still 5. When you click the login button, what will happen? Now the alerts will pop up and click continue, and another, the window pop up. This one is actually the auth client provider to pop up and have a new web window. And when I click the web window, it will redirect me to my local II projects. The auth indicate, you authorize possession, and then you take me back. Now we get back. Now we have click the plus again. Now we have the counter. It's now 6. We have a authentic user account here. So what happened really? When I click the login button, we call the authenticate here. The authenticate here is in which we actually call a web auth provider. Web auth provider is developed by this package, agent.auth package. It will pop up a window to complete the flow. Also, we have to pass the URL. This URL is the URL that before the II. Before the II, the project will this project will hook up with II, but because II only recognize the the web request, the web page request from browser, not from other apps, like Flutter or any native apps. So we have to use a the web browser project to interact with the II. So this one, the web auth provider, will open a browser page to interact with II. So this project, you can see, you can locate this project here, also client demo. Later I will show you the demo here. Also, you can see you can see auth counter description read here, and you can locate the auth client demo. Before that, you have to run the auth. Before that, you have to run the auth web auth provider demo there, and then you get the identity back from II. Then we set the latest identity to the counter class, and we ship it to the actor. Then we have the authenticate identity, so we can increase the number by 1. Increase the number by 1. Finally, the NN function is false, and we can increase the value by 1. It's a little bit complicated to and the last one, the last example, but it is very useful because when you are developing another fully functional Flutter app to interact with IC, you have to understand that the identity is very, very important because like this tree or like Discover or any other app, you have to understand the login logic because we're assuming that you are using distant technology from II, you have to use that. Every application to on the IC is related to identity, so understand it well. Perhaps you can look at this demo very, very closely. Now, let me show you the third one. The third one is called the Ledger app. Ledger app is to demonstrate how to transact ICPs from address A to address B. So if you are a developer from Ethereum or other blockchain, you'll be familiar with transaction. Transaction is very, very basic for blockchain development. So to transact cryptocurrency from ledger A to address A to address B, is also applicable to the IC development. So this example will show you how to write a ledger app using Agent Dart. So before you write the ledger app, you will have to understand what you're doing. Now, on IC is very, very different from other blockchain. The paradigm is different because when if you are familiar with Ethereum, basically when you make a transaction, you may, especially if you are making a wallet client, a wallet app, basically running a code, calling the RBC. Before you call in RBC, you just construct some parameter for the transaction, and you call in the RBC node and RBC function, and transcend. But on IC it's different. On IC, okay, you can call the Rosetta node directly, but Rosetta node is only for exchanges, and they have whitelist on exchanges, so you don't have the authentication for the Rosetta node service on Divinity. So it is very, very hard to test locally in your local machine or local environment. So we have another paradigm to use that. You have to deploy, we call the ledger WASM to your local network. You have to deploy a local WASM, and you have to mint some account in this account with some ISP to the wireless. You mint some account to mint some ISP to the account and deploy the ledger WASM to your local canister, to a local network, and you'll be taking a ledger canister ID here. And then we use the ledger canister ID, and we set up a new agent, and we have another you call identity. The identity. Why we mint this account? Because we use this account to sign transaction. So we have to use this, to momentum phrases. If you're familiar with blockchain, you see the momentum phrases. This momentum phrase will generate this account address to sign the transaction as the sender. Before the transfer, you have to sign the transaction using this account, using this memory phrases, and then you can send the SV to another. To the backend, this ledger WASM is to deploy, and this ledger candidates will be used. But we don't have motor here. It's very, very complicated. Actually, the ledger WASM is generated by Roscoe, developed by Divinity team. So we just use the WASM code directly, and we put the DFX configuration using the custom type candidate and WASM setting here, and we deploy the contract, deploy the code to your local network, and then we can send the transaction afterwards. So let me demonstrate the process directly. Okay. You can see this is a very simple transaction dashboard. You have several input here. The first one is ask you to please create or import accounts. You can create random accounts by clicking this button, and we generate different accounts. However, this account is not meant. They don't have any ICP here because it's created randomly. But this feature only shows that you can create accounts, create signer, create accounts using AstroX, and also you can import some phrases suite. So we just use the phrase we're talking about earlier. Use this phrase to import that. Now we are rich. Now we have this many, ICP. This ICP. Now this is the account ID or address to this account. So this account has this ICP, and we need another, recipient address. So we have a sender, have a receiver. So we just I have a random receiver. Now this receiver have 730 ICP. The balance is actually using the ledger get balance, the Watson function, directly call from the canister, very fast to get the results. We have a recipient address, and we have to input the amount. We input how many ICP we want to send. Like we want to send a 900. You want to send 900 to this address, and this one is the fee. The fee is by default 12301.2601 ICP as the the transaction fee, and then the input memo we have empty or less than 8 characters. You can ignore this one and this one by default. Then we confirm and send. We confirm that we want to send this one to this one, and just confirm. After that, the transaction is processing. It's very super ugly, but it works. We have a block height 18. We receive a balance after send. The balance change is this many. The transaction fee, the transaction amount. Then you can see the balance change. Now, previously you see this is 900 fee, and then this one is increased by 900. So it's very simple by business model. But however, it's very ugly. The UI logic. UI logic here is very, because it's many input states. So if you're familiar with, Flutter Demi, you'll be able to write it more simpler. But to demonstrate the code, I write up in about 30 minutes. So it's pretty much ugly for me, but it actually works because the inside logic is very, very simple. So let me just show you how the inside logic of transaction is actually here. So we have a ledger. This ledger class is already inside the agent package. You can call it directly, but you must initiate it before everything happened. You just use the create logic. This is the the ledger canister and the ledger IDL. You can use it to initiate the ledger function, ledger class. Then you can use the ledger to get the block height, and you can query the balance use the gap balance. Then after that, you will get the ICPTS class to get the result. To get the balance chain. Because this logic is business logic is very simple. You to just input some parameter and send. And this is done. It's very simple. Agent is already have a ledger inside, so you don't have to write too much logic to complete the flow. But you can focus on the complete UI. Maybe much better than I do. So I don't want to talk about too much UI structure, but just show you the concept of using the ledger and using the agent to complete the product flow. So here's this the examples we want to cover in this live event. So the next session is the Q&A. Basically, you can ask me anything about Agent Bird. Yeah, I'm not here. Yeah, anyone would like to ask me a question, please turn on your mic. Yeah, just go ahead. So how about this? I'll just continue with the later session. Maybe you wanna digest some information or ask a question afterwards. That's okay, and you can type in every question anytime, anywhere in this channel. So let me continue. So what's the future plans for Agent Bird? We'll do about that. We are going to release some bounties for features and modules for Agent Bird, and we are going to release some bounties for test coverage and documentations. And we want to integrate with latest NNS and SNS interfaces and other interface modules. Yeah, because Agent Bird is very early stage development, so we have very low level features to has already implemented. But in real development, we have actual we encounter some problem when we are using when we are interacting with the canister IDL, especially on IDL. Let me show you some example. Like this one, the IDL interface is very hard for a Flutter guy or a Dart guy to write this. It's not very convenient to understand because it's actually the JavaScript logic developed by created by the DIDC function by Rust and generate this one. It's already generated by the DIDC compiler. DID compiler it is a JavaScript specific languages description thing, and to the TypeScript, JavaScript has a interface description. It's pretty simpler in this example, but however, when this one is growing bigger, this interface is very much complicated than ever. Let me show you the agent part. When I was developing the ledger class, it's become my nightmare because in Dart lang, everything is class. So in Dart lang is an OOP, language is almost used everywhere. Class is everywhere. So to be able to use the class, when I access the the nanos or sets in the class, where I have to write class almost everywhere. Unlike the TypeScript, you can just describe the interface directly. So in Dart, you have to manually write everything. So this file becomes the nightmare I've got, because I have IDL everywhere and I have complicated nested IDL. So I have to write complicated nested classes I've got. So it's very easy to make mistake. It's very hard for the people to maintain, to update this, various classes. So we have another job to do, or another bounty for, everyone. Just like the JavaScript did, or the Rust did for JavaScript, we want a candidate compiler to compile the candidate file into the Dart recognized classes. So it will reduce the manual written job for developers, and it will reduce the risk that we make mistakes, and will make us easier for people to write qualified applications, and easier for us to update our apps. So this is critical job, critical bounties for open bounties for everyone. So this is most I want from Agent Dart, but I don't have enough time and spirit to complete the job. So this is we would like to invite everyone to participate, and will be reward and contribute to the community. For the rest part is test case and documentation is very important for newcomers and everyone interested to maintain the library. We don't want to be a single identity to maintain this library. We want to integrate with the latest lessons and interface, because afterwards the governance and the staking feature shall be implemented by every app, especially on SNS. SNS is very powerful. We want every app to be able to governance themselves. So we want SNS interfaces integrated by the agent Dart. So we invite everyone to participate in the bounty. Yeah. So basically, this is the end of this live event, and this is what we are trying to share with you guys, and hopefully today's conversation will be a little bit clearer for people to use Agent Dart to develop your Flutter app on IC. So thank you. If you have any question, please type in the channel. We're happy to answer all of them, and to talk to you guys when we are available. So let me hand it back to you, Alex.
All right, thank you, Michael. So if everyone has any other questions, please use the Agent Dart channel, and we'll get all your questions answered. All right. Thank you so much, everyone, for participating, and we'll see you all till next AMA live stream.